Subscribe to our channel at Goodwill Groups of School, a bargain.
Yeah, good day over there. I'm sure you are staying safe, and so we are here. This moment we want to look at angle of depression. This is mathematics class, so we're looking at angle of depression. In the previous class we introduced what we can generally have when we are looking at an object. It is either the object is located at a level that is above our eye level or below our eye level, and we've treated angle of elevation, that is the view we have when looking at an object that is above our eye level. Now, angle of depression is the view we have when we are looking at an object that is below our eye level. Now, let me just put that on the board. Represented as, making use of this diagram here, that point is representing our eye level. That is the level of your eye now. And of course, always you should just have that picture that as when you are looking at an object, the level of your eye will determine the kind of limitations, boundary, space where your eye may not see things that are beyond that level. That is where we take as our eye level, and it is always preferable as a broken line like that. It is more or less like imaginary, just to help us to understand what we are trying to talk about. Now, from our eye level, we are looking at an object that is below. Then that means the object is located somewhere down here. So, the angle that we have in between our eye level and the line of view, that is what gives us our angle of depression. So this is the angle referred to as our angle of depression. Now, from what we've done so far from angle of elevation, you should be able to recall that we'll be moving to getting a right angle triangle from here, so that it will be possible for us to calculate some things we might be asked to, probably the value of the angle of elevation or the distances between the viewer and the object in question. Now we are going to be taking some questions as examples to explain more on what we have when talking about angle of depression. Now, as we try to look at the examples, let's just make mention of some of the views of objects we can identify as a view giving us angle of depression, and this includes viewing a ship that is on the sea moving, and while you are standing by the seashore, that is giving us an example of angle of depression. Also, when looking at maybe a pair of shoes on the floor, that is giving us an angle of depression. When you are viewing an object while you are inside a story building, you are at the top in the building, and you are viewing an object that is outside downstairs, then that is also giving us an example of angle of depression. So with these few ones, you should also be able to now check and give many more examples of what angle of depression should look like. Now let's take this example. Alright, let's take a look at this question. A boy views a ship at sea at an angle 60 degrees. If the horizontal distance between the boy and the ship is 20 meters, what is the actual distance between them? Now, from this question, it has not been indicated whether we are looking at angle of elevation or depression, but by you remembering that once the object you are looking at is below your eye level, that should be angle of depression. So once you see the question, the boy views the ship at sea. The ship is on the sea. Definitely that is below the eye level of the boy, who is the viewer. So the angle we are given here is definitely the angle of depression. Now, our angle of depression is, take a closer look at this. I need you to take a closer look at this. It is always advisable to draw a diagram, and you having a correct diagram helps a lot in being able to get the correct answer at the end of the day. Now we have, this is where the boy should be. I have the boy at that point, and that is where the eye level of the boy is. So we have the broken line which represents the eye level of the boy. The ship is somewhere down there. That is the ship. We are given the angle here, and that angle falls in place right there. Now we said we are expecting to get a complete right angle triangle, which helps us to apply those trigonometric ratios we have learnt earlier on. So this part helps in completing our right angle triangle, and of course the angle at that point should be angle 90 degrees. So from here, the question we are asked is the actual distance between them, that is between the boy and the ship. This is the actual distance. If you go by this, this is indirect, is moving this way, but this one is direct, so that is what is coming as our actual distance. So we take the value for this to be an unknown value, and then we are given the horizontal distance. This is where we have an horizontal line here. So that will give us the horizontal distance between the boy and the ship. Or if you assume that, okay, coming to the level of the ship, then of course the distance here and the distance here will give us the same value, and that is what we are given in the question, 20 meters. So we're looking for x. This is a right angle triangle. The angle 60 we are given located over there is relating with the adjacent side given, and here now we are looking for the hypotenuse. Which of the trigonometric ratios takes the adjacent and hypotenuse along? That should be the cosine. So we have cos theta should be equal to adjacent over hypotenuse, and cos theta, that's cos 69, should be the same as adjacent over hypotenuse. And from here, if we find the value for our cos 60, that is 0.5 or 1 over 2, which is the same as our 20 over x. And from here, we have the value of x can be gotten as 20 divided by 0.5, and our x comes out as what? That is 40 meters. So that will be the actual distance between the boy and the sheep. I should believe that this is clear to you. You can go over this as much as possible to gain the proper understanding of it. We are going to take a second example to explain further. Alright, so this is another question for us to look at. A man views his car from a story building 9 meters high. If the distance between his eyes and the car is 18 meters, what is the angle of depression made by his view? Now, let's work on this together, and as I will always say, you should be able to get a correct diagram for this question. And this question here is talking about a building. Just applying our normal, our common sense tells us that the building is standing vertically. So the building should just be represented by a vertical line. That is all, we've represented the building. And of course, the building is standing on horizontal ground. So you have this. So this is the ground, this is our building. We have, the building is 9 meters high. So this is 9 meters right there. Now, the man is viewing his car from that building, which means the car is maybe on the car park downstairs. So definitely the man should be somewhere up right here, and then the car should be down on the ground over there. So you should complete your triangle by having the third side linked by those 2 points, the point at the car and the point at which the man is located. Now, don't get confused at this point. This is where the man is. The man is viewing downwards. The angle of depression is connected to his eye level. This is the eye level. So this is where the angle of depression is. You shouldn't make mistake of putting it here. Now, we are asked to calculate the angle. So that means we can make use of that unknown value or symbol to represent what we have. Now, what other information is given in the question? If the distance between his eyes and the car is 18 meters, so the car and his eyes, the distance is 18 meters. What is the angle of depression? Now, we should consider this eye view, this line representing his eye view is purely horizontal, and of course the ground is purely horizontal. Now you should interpret your question from there. Having this horizontal and this horizontal, they are parallel lines. And if these two are parallel lines, then we should look for the alternate angle between the two of them. So this line is connecting these two parallel lines, and so this angle here is alternate to the angle down here. So that means our angle of depression here comes as the angle of depression here also, or comes as the angle of elevation, if I want to really apply it correctly the way what we are studying is, because if someone is at this point and looking the other way, it is angle of elevation the person is having. So the angle of depression is here, and it forms an alternate angle with what we have here, and those two angles must be equal. Now we can now come and work with this triangle. So we have the given angle, this side is opposite, and then this side also given is the longest side, which is hypotenuse. We are looking for the trigonometric ratio that carries opposite and hypotenuse alongside with the given angle, and of course that should be the sine. So we have sine theta is always given as opposite over hypotenuse, and in this case it is that angle theta we are looking for. So we have our sine theta is equal to opposite is 9 meters, then hypotenuse is what we have here, 18 meters. Now we have sine theta is equal to, this is 1 over 2, or which is the same thing as 0.5. So now for us to get the value of our angle, we can take the sine inverse of 0.5, and the sine inverse of 0.5 is 30. So this gives us 30 degrees. That's gotten that from our 4-figure table or from our scientific calculator. And I hope this is very clear, simple, and interesting. So just settle down with this and get more questions to work on for further understanding of what we have looked at today. God bless you.
Please subscribe to our channel at Goodwill Groups of School, a bargain.